Hi everybody, in this video I'm going to go over the Unit 1 quiz study guide. So our first question said which number line should be used to estimate the square root of 52. So essentially when we draw a number line out to estimate a square root, we're looking for the two perfect squares that square root would be in between. So 52's closest square roots would be a little bit bigger than 40. So 52 is a little bit bigger than 49, but it's smaller than 64. So then that would be the third number line on here. So again, 49 is a perfect square because the square root of 49 is 7, which is a whole number. And then 64 is a perfect square because the square root of 64 is 8, again, which is a whole number. So I would know that the square root of 52 would have to be somewhere in between square root of 49 and 64, square root of 64, which would be the same thing as being in between the numbers 7 and 8. So I know its value should be like 7 point something. For the next question on here, it says George is trying to estimate the square root of 92 using a number line. So for that one, the first question it says is what value would go where the question mark is. So say that we're trying to figure out like a halfway point in here to get a better idea of where exactly the square root of 92 would fall. To figure out the value of the question mark, well, 9 times 9 was 81, and 10 times 10 was 100. So we would definitely have to do 9.5 times 9.5 to figure out what's underneath the question mark, or to figure out what the question mark is. So 9.5 times 9.5, that's the same thing as 9.5 squared. When you do it, you should get 90.25. So then that should give you the idea then, okay, so if this value is 90.25, then the square root of 92 must be a little bit bigger than the 9.5. So you might estimate it to be like maybe 9.6, even if you put 9.7, that would be fine. But definitely should be a little bit bigger than the square root of 90.25, which we knew was 9.5. So we like that halfway point again because it gives us a little bit better idea of where exactly square root of 92 would fall. The next one says, what is the value of the square root of negative 49? And you may just remember that anytime you see the negative underneath the square root symbol, you might remember that that's not a real number. But keep in mind too, the square root of 49 would just be 7. But if I do the square root of if I do the square root of negative 49, I'm looking for what number do I multiply by itself to get negative 49. But 7 times 7 is positive 49. Even negative 7 times negative 7 is positive 49 because negative times a negative is a positive. So there's no way that you can multiply one number by itself and get a negative 49. So because we can't answer that, we would refer to square root of negative 49 as being not a real number. The next one is an error analysis question. It says Jimmy's converting 24 over 5 to a fraction. And it says, what is his mistake? And again, when we say error analysis, it essentially means that you're looking for this guy's mistake. So we're supposed to convert 24 over 5 to a fraction. And I know anytime I see a fraction, I think, okay, I have 24 divided by 5. And I really like that phrase. You guys have heard me say it before. Top dog in the house, which reminds me that the numerator, which is the 24 is the top dog, needs to go inside of the division symbol. So hopefully you're noticing then that the 24 should have been inside of the division symbol and the 5 should have been outside. So he kind of mixed up those two numbers. So then I can look at my answer choices and it looks like it's going to be the first one for me. It says Jimmy mixed up the 24 and the 5. The numerator, top dog, should have gone inside of the division bar, but he put the 5 in there. And then from there, moving on to our next one, number 5, it says what fraction would be the equivalent to the decimal 0.4 repeating. So I know this right away that it's just one digit repeating, and whenever I have one digit repeating, that means that my denominator should just be a 9. And the digit that is repeating is what goes into the numerator. So just note, since the first one's 4 over 99, but if I have 99 in the denominator, then 2 digits are going to be repeated. If I had, say, 999 in the denominator, then 3 digits would be repeating, and so on. So this is just one digit repeating. So then I should have 9 in the denominator, and then you could keep in mind 4 over 10 would be 4 tenths. That would just be like 0.4, but a terminating decimal, it wouldn't be repeating. And same thing with 4, well, or similar with 4 over 100, that'd be 4 hundredths, so 0.04. And again, that would just be terminating, it would not be repeating. If I take a peek at number 6, the number 15 is an example of perfect square. No, it is not. False. So remember, perfect squares are essentially like the product of a whole number in itself. So like 1 times 1 is 1, or 1 squared is 1. So 1 is a perfect square. 2 times 2 is 4. So then 4 is a perfect square. 3 times 3 is 9. So 9 is a perfect square. 4 times 4 is 16. So 16 is a perfect square. But notice I went straight from 9 to 16. So 15 would not be a perfect square. And just note too, you can find all of those, well, not all of them, but you can find perfect squares listed between like 0 and I think maybe 225 are listed in your notes packet. And then you can also see some written on that multiplication chart that we gave you guys on our meet and greet day at school. From there, the next one says convert each fraction to a decimal. You could do these with long division. You could technically even do them in your calculator if you really wanted to. Some people like to convert them to a mixed number first. That's also fine. So for 25 over 4, say I need the 25 to go in the house, and then I'm going to have the 4 outside. So 4 goes into 25 6 times, and 6 times 4 is 24. And when I subtract that, I'm left with 1. So then I'm going to have to put my decimal point, and then I'm going to have to add a 0, and I can bring my 0 down. So 4 would go into 10 twice. 4 times 2 is 8. When I subtract, I'm still left with 2, so 10 minus 8 is 2. And then I'm going to bring down another 0. 4 goes into 20 5 times, and then 5 times 4 is 20, so I know I'm done. So then that tells me that 25 over 4 should be equal to 6.25. And again, you could have done that by changing that to a number. You also could have done it in your calculator or checked it in your calculator. So for that one, I'm getting 6.25 or 6 and 25/100ths. And then for 7 over 8, I need to put the 7 in the house because 7 is the top dog. Right away, I'm going to have to add the decimal because 8 doesn't go into 7. But 8 goes into 70 8 times. 8 times 8 is 64. When I subtract that, I'm left with 6. I can bring down a 0. 8 goes into 60 7 times, and 7 times 8 is going to be, 56. And then I'm left with 4, and then 4 goes into 40 5 times. So 5 times 4 is 40, and I'm left with 0. So then I know that 7 over 8 is going to be 0.875. So again, no terminating number, which should make sense. So then when I go back to Schoology, I got 0.875 there. And just moving on from there, so when we're looking at the next one, 1 over 9, notice you have a 1 in the denominator. So when you look at 1 over 9, notice you have a 9 in the denominator, so you should hopefully notice then that that's going to be a repeating decimal, and it's just a 9 in the denominator, just 1 9. So then that means that in your decimal, you should just have one digit repeating, and it should be whatever digit is in the numerator. So that would be 0.1 repeating. 3 over 4, you could convert that using the long division like we did on the last question, but you might even realize 3/4 is literally like, if you had 3/4 of money, that would be 75 cents. So a lot of times people know that one without the long division, but if you need to use the long division, that's fine. So for 15 over 99, notice it's a 99, so that means that then 2 digits should be repeating. So then the digits that are repeating should be what's in the numerator, 1 5, so then I'm going to be picking this one. For 1 over 10, that's 1/10. That would just be 0.1. And then for 7 over 11, that's definitely probably the trickiest one out of all of these. We kept in mind before, it was if we had 99 in the denominator, then that was easy to see that we had 2 digits repeating. But you figure 11 times 9 would give me 99. And if you were going to multiply the denominator by 9, you'd have to multiply the numerator by 9. And I can kind of show you guys what I'm talking about. So if I have 7 over 11, if I multiply the 11 by 9, I'd get 99. But then if I want to change my fraction, I'd have to multiply the numerator too. And then 7 times 9 is 63. So then if I have 63 over 99, I know that's going to be 0.63 repeating because I'd have 2 digits repeating and they'd be the numbers that were in the numerator. So then that last one should make sense. And I mean, I guess you could technically figure it out by process of elimination or using your calculator technically as well. For the next one, the number 8.25, that should be a terminating decimal. Remember, terminating is a decimal that ends. And remember that we're saying we're saying the rational numbers are numbers that are either going to be able to be written as repeating or terminating decimal. So since it's terminating, it would have to be rational. And the next one's very similar, but with different numbers. So you see 0.5, and the 5 has the line on top. So that means that this is 0.5 repeating. So then this is a repeating decimal. And again, rational numbers are numbers that can be written as either repeating or terminating decimals. So then that means that 0.5 repeating would have to be rational. And this next one, the square root of 33. So we're deciding if it's rational or irrational. I keep in mind 33 is not a perfect square. And when you do the square root of a number that's not a perfect square, it's always going to be irrational. Because notice if you had the square root of a number that is a perfect square, say like the square root of 25, well, the square root of 25 is 5. And 5 is a number that's terminating because it ends. So that would make that be rational. And same thing with like the square root of 36. That would be 6 because 6 is, and 6 would be rational because it's just ending. It's a terminating number. But the square root of 33 is going to be in between. And we're not going to be able to find, say, like, I don't know, you wouldn't just be able to say, like, 5.5 is 33. You're not going to be able to find something like that. It's literally going to go on forever. So if you are stuck on that, though, you could take a peek in your calculator and you would see that the square root of 33, it's going to go on forever, but it's not repeating. And that's what irrational numbers do. And this last one says 0 is an example of a rational number. That should be true because 0 is terminating. It's not going on forever like pi or like the square root of 33 or any of those would be. 0 is just terminating because it ends, so it would be rational. Anyway, I hope this was helpful for you guys looking at this study guide. Please let me know if you have any other questions. Thanks for watching.